bipolar junction transistor. The goal of this presentation is to help you determine the type of BJT you're using, NPN or PNP, and the pinout configuration. A bipolar junction transistor, or BJT, consists of three terminals: a collector, base, and emitter terminal. The connections through the base to collector and base to emitter terminals can be thought of as a PN junction, or diode. By definition, the base terminal is always in the middle, between the emitter and collector, as you can see from the image. In order to determine the type of BJT you're using and also the pinout configuration, we're going to use the Agilent 34401A digital multimeter, which is the multimeter provided to you in the labs. First, turn on the multimeter. Then press Shift, which is the button enclosed in the red square, and the CONT button enclosed in the green square. This will put your multimeter in diode check mode. And what diode check mode does is it measures the voltage across the diode in forward bias. In order to confirm that your multimeter is in diode check mode, you'll see a diode icon in the lower right corner of your display. To determine the type of BJT you are using, follow these steps. First, connect the negative terminal lead of the multimeter to the base terminal of the BJT, which is the center terminal. Then connect the positive terminal lead to any other pin of the BJT. If the multimeter reads something other than open or overload, then the transistor is PNP, otherwise it's NPN. And the reason behind this is, the diode check function of the multimeter measures the voltage across the diode in forward bias and will not measure anything for a reverse bias diode. Since the negative terminal lead is connected to the base and the positive lead to another BJT pin, according to the image, if there is voltage measured, then the transistor is PNP. If you reverse the polarity, and the multimeter should read open or overload, since it will be a reverse bias diode. If the transistor is NPN, the positive terminal lead of the multimeter should be connected to the base pin and the negative to any other BJT pin, and there should be an output voltage read at the multimeter. To determine the pinout configuration of the BJT, we will use the multimeter again, still in diode check mode, to perform the following procedure. Depending if your transistor is NPN or PNP, connect the proper multimeter terminal to the base pin, see the table below. Then connect the second multimeter terminal lead to another BJT pin and record this value. Do the same for the last pin of the BJT and record that value. The pin that gives a higher voltage voltage drop across the emitter pin across the diode is the emitter pin, and the other pin is the collector. The reason for this is the emitter terminal is always more highly doped than the collector pin. By this logic, and as you can see from the equation, that the doping density is directly correlated to the magnitude of the voltage potential. Therefore, the voltage potential across the emitter terminal is always going to be greater than the voltage potential across the collector. And here's just a bit of additional information you might need for Lab 7. Thank you for your time, and have a wonderful quarter.